So thank you to the organisers for inviting me to present the work of Stop Work Package Free. So I'll try and give you an overview of what we have been doing in this work package, but particularly I'm focusing on work we've been doing with obesogenic environments and metabolomics and ultra-processed food, as I think this is perhaps most relevant to the aims of the conference today. So the main aims of Work Package Free, the Work Package Free is basically focused on primary research, looking at risk factors and molecular changes in children based in observational population-based cohorts. So the aims of this work package was to identify causal pathways that are supported by sound evidence and are biologically plausible and actionable. So the ambition was in fact three kinds. So be able to connect different levels of evidence, ranging from geographic investigation of distal determinants of obesity. So we're talking here about aspects of the urban environment, down to proximal individual behaviors. So how does this affect physical activity? What are the role of different dietary habits, down to intermediate molecular changes, which can affect propensity or risk of overweight and obesity in childhood. We aim to apply innovative statistical methods, such as mediation analysis, to explore causal changes across the levels, causal chains, and to identify a limited number of biomarkers that could hopefully be used downstream in the project with the trials that are being done in Work Package 8, I think. So I'm not sure we've managed to do all these aims, but I will show you some of the achievements of the project. So here you can see a slide showing the different cohorts from across Europe that are involved in the research, including children here in Ljubljana. Well, I say here, I'm here in the UK, where we worked on assessment of the obesogenic environment. So these broadly give the range of topics that we have been researching, from systematic reviews, prenatal risk factors, particularly antibiotic use, which points to, again, the role of the gut microbiota in obesity risk, multi-omic analyses of birth weight, child biomarkers relating to pre-pregnancy BMI, built environment, ultra-processed food, and molecular signatures, both metabolomic and epigenetic signatures of obesity and that may contribute to childhood obesity risk. We've had a strong focus on ultra-processed food, and we've been examining gut hormones as a mediator for signaling, nutrient signaling, and appetite regulation. But today I'm going to concentrate on systematic reviews. I'll present some work from our work on the built environment and some work on ultra-processed food and its molecular signatures. And if I have time, I'm going to talk about some work of metabolic signatures of rapid growth and childhood obesity. So first, the urban environment. So we talk all the aspects that may have, that may be distal determinants, including factors such as air pollution and noise, but also the built and natural environment, such as the structure of cities and how much green space there is. So first, we contributed a systematic review to give a summary of the evidence available today. And actually, from 11 studies, we found there is a consistent and strong association of NO2 and nitrogen oxides, which are a form of air pollution closely related to traffic, with childhood obesity. And there was strong evidence of built environment characteristics that are supportive of walking. And these include the density of buildings and their intersections from 7 studies, and access to parks and availability of green spaces in parks. So this was 10 and 5 studies that had strong associations with obesity. We also looked at noise, but this is, there's too few studies in this area. So clearly the literature points to a role of the built environment in childhood obesity. However, it was noted that these were all considering exposures one by one. We were interested to look at these holistically. It's what we call an exposome approach, looking at many exposures, and also trying to tease out what aspects of child behaviour might be affected by the built environment. So I'm going to present some work conducted in these 6 cohorts, which was part of the Helix project. It's still under review. And the Helix project brought together 6 existing birth cohorts. And from these cohorts, we have what we call the Helix sub-cohort of just over 1,500 children, who we perform very detailed assessments of their lifestyle with physical activity questionnaires validated with accelerometers, and asking the parents to draw on maps how they get to school, and then all commuting routes. So we applied a systematic assessment of the environment to all the cohorts participating, these including many different variables related to the built environment, traffic, and natural spaces. So the outcomes included various measures of physical activity, sedentary behaviours, and daily time active commuting. So here, this is what the parents actually completed with the nurses. They drew the map, their route to school. So these plots, show the strength of association on the y-axis and the estimate positive or negative on the x-axis. So if we look at moderate or vigorous physical activity, the strongest associations that supported this were green space around the home, but also around the school. These showed that actually aspects of the built environment, such as population density and how connected to the around the home, were negatively associated. Again, for physical activity outside school hours, we saw a similar pattern. For sedentary behaviours, so how much they watch TV, play computer games, green space had a negative effect on this, and population density again had a positive effect on this. For active commuting, what was important was the density and richness of facilities around the school and the density of buildings around the school. Again, school green space at the home, and also if it was a mixed use of the land, was negatively associated with active transport. So in summary, these findings suggest that areas with more green space, building density, and that are less densely populated may be supportive of physical activity and active transport. I think this backs up what we're seeing with this rural urban trends, and the associations were consistent across the cohorts, suggesting that potential interventions to modify urban design could be applied across cities. So our findings suggest that these designs need to include a combination of different urban indicators. So that's giving you a taste of the geospatial analysis. Now I'm going to move down a much smaller level. So here we're talking about metabolomics. So when we talk about metabolomics, it's a post-genomic technology. So we think the genome does have a small influence on child obesity, but then the genome is regulated by epigenetic factors, going down to proteins that are produced by the genes, and these have a strong role in metabolism. So we're looking at the small molecules, the metabolites that are produced by all these biological processes. So it's a very interesting platform of things of analytes to look at because it's strongly affected by genome. But of course, it's very strongly and directly affected by the diet and many other aspects of the environment. So it brings all these things together. So we think it could be quite useful in this sort of research. So we performed a systematic review of metabolomic studies, and most studies were from the last 10 years, so it's relatively new. And we found 27 different studies in blood, cross-sectional, and we did see a consistent signature of childhood obesity, particularly these increases in certain amino acids, but also carnitines and various lipids and steroids. Now, basically, the evidence really appears that this is an effect of childhood obesity. We were interested here in this other arrow as whether these molecules could be causally related to child obesity. Do they represent metabolic shifts that increase propensity to weight gain? And there was very little evidence. 5 small studies had looked longitudinally. So we have various lines of research that I will present now that have aimed to address this. But first I'll talk about how the environment can affect the metabolic signature. So this is a study published by collaborators with InStop earlier this year. This was in JAMA Pediatrics, and it was one of the largest cohorts in the UK, the Ausbach cohort. And this is based on food diaries and classifying their diet according to the NOVA classification of ultra-processed foods. So foods are classified into minimally processed, up 4 levels of processing until we talk about ultra-processed food. So we're talking about ready meals, ready-made pizzas, biscuits, and so on. And actually, this is something that we've been eating for a long time in the UK. One thing that is very clear, I don't know if you can see this table, but if we look at the higher levels of socio-economic occupational classification, in the highest group, they have the smallest percentage. It's a very clear trend of ultra-processed food, and those in routine manual occupations have the highest percentage of ultra-processed food. Here is the 5th quintile. So it's this pattern of diet is very strongly related to socioeconomic position. And we see that when we look at the quintiles of ultra-processed food at 7 years, that we can see differences in trends in body mass index or fat mass index starting to become very clear by about 13 years old. So this obviously has a very strong contribution to divergence in obesity risk, particularly among socioeconomic classes. And it's around 60% of the diet in Ausbach actually comes from ultra-processed food. So it's an enormous part of our diet today. So we use metabolomics to try and tease apart the mechanisms. We applied NMR metabolomics to profile the different changes in the blood reflected in metabolism and diet. And we can see from this plot, these are all the different molecules, and we see very strong associations for various molecules. And the key ones that change were these branched chain amino acids, which were reduced, increases in glutamine, another protein non-essential, and also citrate, which is a very widely used additive. And if we then examine the role of these different molecules in fat mass trajectories, we also see that higher levels, these are the quartiles of the metabolite. This is adjusted for baseline adiposity, showing fat mass trajectories over for up to 17 years, from 7 years. We see there is a strong dose response. Some of these, such as leucine and citrates. So this points, so I'm not actually going to talk about the next slide. I'll go to the end now. But this does point to various different chemicals such as lower levels of amino acids, which is related to lower intake of proteins, being important for fat mass gain over from 7 years onwards. So we've really tried to tease apart the mechanisms here using metabolomics that are driving the effects of ultra-processed food. Okay, so I'll wrap up there now, Franco. Thank you.